Hello, and welcome to another Unreal Engine 4 tutorial. In this video, we're going to be going through how to make a spline-based conveyor belt system. We're going to be working mainly in Blueprint and a little bit in the material editor just to get a panning effect and to scale the textures for the spline mesh. Before we get too deep into this, I just want to say I originally made this in Unreal 4.18 for a game that I'm working on. And for this tutorial, I attempted to make it in 4.23 and had issues with for each loops that were giving me errors, and I have no clue why. I copy pasted everything into 4.20, which is the only other version of Unreal that I had installed, and it works perfectly fine. So if you're doing this in Unreal version 4.23, be warned, you may have issues with it, and I don't know why. If you have better luck, let me know. If you figure out what the issue with the for each loops is, let me know. I could not figure it out after about half an hour, so I just gave up and did it in a different version of Unreal. So apologies for those of you using the latest version. Seems like there's a little error in there that I'm not really sure why it exists. So without further ado, let's jump into the editor here. And the first thing that we're going to do is import a mesh that I've created for this conveyor belt. And we're going to look at the mesh, and I'll explain why it is the way it is. So we're importing it. We're just going to delete this material. So what I have here is this test belt FBX. And you can see that I've kind of cut the edges off of it. And it's just sort of a loop that goes around, kind of like the rubber on a conveyor belt that you would see. So a few things of note are, if I look at the UVs, you can see it's all collapsed down to one square. And the reason why I've done this is so that when we're panning the texture, it will pan all the way around in a nice smooth loop. And one thing that you'll note is if I click up here and then I click down here, you can see that if you look on the left over here, you can see that the top and the bottom are sort of flipped so that it will pan in a nice, the texture will pan through all the way around seamlessly. So that's all that we have there. We'll make a material for this, and then we'll make that double-sided so this won't look so weird in the center. It'll actually, you'll be able to see the texture panning on the inside as well. So that is the model that we're going to be using. So the first thing we're going to do after that is to create a blueprint for the conveyor belt. We're going to call that BP_conveyor belt. We're going to open up that real quick. We are going to add a spline component. This is going to be the basis of what we're doing here. And basically, that's just going to add a spline with 2 points, which is all we need for now. We'll compile that and go in the construction script. And the first thing we're going to do is we're going to get the spline, and then we're going to get the number of spline points. And then we are going to subtract from this. We're going to subtract 2 because what the number of spline points is doing is it's getting the number of spline points, but then we're going to do a for each loop. Oh, sorry. We're gonna do a for loop. Sorry, not a for each loop. So we're gonna do a for loop, and so that's going to go from 0, whereas the number of spline points is basically, if we were iterating through that array of spline points, it would be going 1 over. So we don't want to do that. And also what we want is we don't want to make a spline mesh for the last point. We just want to make it up until the last point. So we want to subtract by 2, and that will give us the correct number of points. And then we are going to get the location of location and tangent at spline points. So we want this for 2 different points. We want this for the first point that we're looking at, and then we're going to subtract 1 to look at the previous point. So we're going to duplicate this and plug that in. So now we're looking at the current point and the previous point to kind of get an idea of where the mesh should be stretching between. And then we're going to add a add component add spline mesh component. And we are going to just leave this the way it is, but we're going to set start and end points on this. So set start and end, and it's going to start. It's going to start here and end here. So now, if we look at this, actually we need to change a few things in here first. We need to change the mesh. So we want this to be our test belt. We don't have a material for it yet. We're also going to do a few other things. I'm going to set this at -50 on the Z so that when we're editing the spline points in the editor, we can actually see where those spline points are. And then we're also going to set this to block all. And then I've made a little mistake here. I think what I did wrong was I plugged these in backwards, or maybe I should be adding. I think that's what I did wrong. Yeah, I should be adding point here. Wow, I'm having a lot of trouble typing. There we go. Yeah, so I should have been adding, not subtracting the point. My bad. My notes are scrawled very hastily. So now we have a spline here. And a couple other things that I didn't mention about this mesh, and the reason, like you may have noticed that for something that is kind of boxy, it has a lot of vertices in it. And that is because the way that splines interpolate, it needs more vertices to really be accurate to the curve of the spline. And we'll see that manifest in the collision in a little bit. That will give us a really good idea of what it would look like if we had fewer verts. So if I just drag this into the world here, you'll see it looks fine. If I drag this out, it looks all right. If I make a new one and then try and move that around, come on now. So you'll see it curves, and it curves nicely. But then if I show the collision, you can see that the collision doesn't quite follow it well. It's this little brown line here. So the more extreme you get with the curves, the less that's going to actually follow, and that's not really good because say if you wandered over here with your character, on one side you're hitting it sooner than you should, and on the other side you're hitting it not as soon as you should. So we're going to want to fix the collision for this real quick so that it does not become an issue later. So what we're going to do is we're going to turn the UVs off. We're going to show collision, and then we're going to delete this collision. And what we're going to do is pretty simple. We're going to add a box, and that'll conform to the shape of what we have. But what we want to do with that is we want to make it smaller, and then we want to duplicate this a couple times so that we have multiple different, or not multiple different, but we have enough vertices in here spread out far enough that we're not creating an issue with that interpolation. So that looks all right. That should be fine. So now if we look at it, you can see that because we have multiple different segments here with extra vertices, it's a little bit more true to what the shape of the spline mesh is. So now we have our start and end points set up. One thing we want to do also is we want to keep track of the spline meshes. So we're going to promote this to a variable just to get the correct variable type. We're going to call this mesh components, and then delete this, and then grab this and add, well, not map, add array. Oh, sorry, I didn't turn this into an array. So this should be an array here, yeah. And we're going to add the one that we just created to that. So every time it makes one of these, it adds it directly to this array. And we're going to use that later to do some texture effects, but for now, that should be good. And so now that we fixed the collision, let's just go ahead and make the material that we're going to put on this so that we can start looking at what we're going to do with that. So we're just going to call this material conveyor belt. And the first thing we want to do is grab a texture coordinate. And we're going to scale this by 2 on both the U and the V. We're going to get a texture sample. And we're just going to grab something that's in the engine. It's grid. I'm not showing engine content. There we go. So you want to go to this little eyeball down here and go to show engine content to see this texture if you don't already have it clicked. And we're just going to click this T 1x1 grid. I think that's the right one. Yeah, that's the right one. We're going to plug that into the base color. And then we're going to do some transforms on this real quick. So first of all, we're going to want a scalar parameter. So I'm holding down S to get scalar parameter. We're going to call that X scale, because as we're creating a longer conveyor belt, we want it to scale along the X so that the texture repeats instead of stretching. We're going to set the default value on that to 1. We're going to create a constant scalar, and we're just going to leave that at 1. So that's going to be our Y, because we're not going to scale on the Y. You could theoretically scale on the Y if you wanted to, but we're not going to do that here. We're just going to, we're not going to scale the conveyor belts in the width direction. So we're going to append these two together. And then we are going to multiply the texture coordinate by these scalars that we've just appended. So now that should scale the texture appropriately depending on what we feed in. And then real quick, I'm just going to also subtract. Oh, that's the wrong thing. I'm going to subtract. I'm really not typing very well today. Okay, so we're going to subtract from this 0.6. This is just a fudge value that I've thrown in here so that the grid lines up where I want it to. You don't really have to do this. It's just so I can show some things a little bit easier and so I can line the collision up later. But so we're going to plug this directly into the texture sample, and then we'll have the basis of our material. We're going to make some more changes in here later, but this should work for now. We're going to throw that onto the test belt. Hopefully that'll compile soon so we can see it. Okay, so you can see it now. So you can see currently this texture is stretching because we're not feeding anything in here to tell this what that X scale should be. So now we're going to go back into the construction script on the conveyor belt, and we are going to do something real quick, pretty simple. We're going to set scalar value, scalar parameter value on materials. We're going to call this X scale. And then we're going to grab some more values from the spline here real quick. So we're going to come back over here, we're going to duplicate this, and we are going to get distance along spline at spline point. And then we're going to plug in that added one that we accidentally subtracted before. We're going to duplicate this, and then we're going to plug in the normal one. And then we're going to subtract float from float. So we're going to subtract the first point from the second point, and then we are going to multiply we're going to divide this float by float, and we're going to divide this by 200. That's just a value that I found works really nice for this texture and this model. A lot of these values that I'm putting in here are just things that you're going to kind of have to feel for yourself if you have your own model and your own texture and all that kind of stuff. So just keep in mind there's a little bit of fiddling with numbers you'll have to do. These numbers don't work for just anything. And then we're going to plug this into the set scalar parameter value on materials, and we're going to compile. And then now if you look, you can see that it is scaling correctly. So as we move this, it will scale the texture for the length. So that's working nice. The only thing you'll see is that there is distortion here as you curve things extremely. So that's just something to keep in mind, is that the more you curve it, the more the texture will distort. So now we've got that set up. So that's the just basics of getting a spline with a spline mesh set together to have the texture scale properly. Now we're going to move on to how we're actually going to get this thing moving objects in the world. So we are going to first and foremost go in here and we're just going to duplicate this. This is a very quick and dirty way to do this. I'm going to call this belt overlapper. This is maybe not the way that you'd want to do this in a final product. This is just quick demonstration purposes, but basically what I'm going to do is I'm going to change the collision here so that this will be an overlapper that will work for this specific mesh. In the long run, what you're probably going to want to do is create something that's got fewer vertices that can do this, because it doesn't really matter what the mesh is. It's more about the collision. Oh, I got an extra collision in there. I should probably check that in the other one too. I think, yeah, I got an extra one in there too. Okay, but in the long run, you basically just want something that's shaped similar and is going to be interpolated the same way, so that it will follow the path, but this is just going to serve exclusively as an overlapper. So we've duplicated the mesh, we've shrunk the collision a little bit because we don't want overlapping people that aren't standing on the conveyor belt to be moved by it, or objects. We just want things that are actually on the conveyor belt, so we shrunk the collision a little bit. So now we're going back into the construction script in the conveyor belt blueprint. And what we're going to want to do is add another spline mesh. So we're just going to copy this one and move it over here. We're going to make a few changes. We want this to be -30 instead of -50. That's going to put it slightly above the conveyor belt so that things on the conveyor belt will overlap with it. Instead of block all, we want this to be overlap all. We don't want it to overlap. I'm going to change it to custom after changing that. We don't want it to overlap world static, because then it'll start moving things in the world that shouldn't be moved, like floors and walls and stuff like that. You just want dynamic pawns, physics bodies, things like that. So we change those, and the last thing we want to change, we can look at the viewport real quick. I guess you can see that it's kind of sitting on top of the other mesh, so that'll just be where our collision is. But the last thing we want to change is we want to go back to the event graph, not the event graph, construction graph, sorry, and turn this to not be visible. Oh, and the other thing I was noticing is that I didn't set this to two-sided, but now you can see that we're only seeing the one, which is the static block all mesh. That is what things will stand on, and the overlapper is just kind of invisible on top of that. If we go back into the material, we can turn that to two-sided, which I forgot to do. So we'll apply and save. So you can see now that's two-sided as it should be. So you see all the way through. And it looks nice. So we're going to go back to the construction script. And now that we have this overlapper, we want to promote this to a variable as well. We're going to delete this, and we're going to change the variable name to, or we're going to change this to an array, just like the other one. And we're going to change the variable name to overlap components. And we want to grab this, add to it, and add this in, so that we're keeping track of all of our overlappers as well, because that's important. And then we also want to do what we did before, which is to add start and end position, and we want to do the exact same way as it was before. So we're just going to plug these in directly. And that should be good. Oh, we got a problem. We did not drag this pin over, so you got to plug in the spline mesh into the start and end point so it's doing the right thing. If we really don't trust ourselves, we can turn this to be visible again just to make sure it's working correctly. But as you can see, it's just doing the same thing, but it's up a little bit, and this is just going to be an overlapper. So if I step onto it, you can see he's just sinking through it. Oh, that shouldn't be there. So we go back. So we've got everything set up now. So now we can step into the actual logic for the conveyor belt. So we'll go to the event graph. We're going to delete these two. We're just going to keep on begin play. And we're going to set a timer by event. And we want this to be firing pretty regularly, so every 0.01 seconds, so 100 times a second. We're going to loop that. And we want to add a custom event, which will be move objects. And then we're going to create another array here. This one we want to just be an array of actors. And this is going to be called moved actors. And this is basically going to be so that if an actor is overlapping two different segments of the spline, it is not being moved by both of them at once, but only one. And also so that we can add the spline in and have it not move itself. So what we're going to do is we're going to set this every time it tries to move. And we're going to make an array that includes itself. So that way it won't move itself, and every time it tries to move, it resets so that it then can move things again. So that's the first part of this. Now we're going to do a loop for each of the overlaps. So for each loop. Okay, and for each of these things, we want to get overlapping actors. So we're going to be checking to see what is overlapping here, and then we're going to do another for each loop for each of these things. And we are going to take this, and we're going to find whether or not this exists in an array. Find item. We're going to check to see if this exists in the array of moved actors to see if this is something that we can move. So the way that this works is if it finds it, it's going to return the index that the actor was at. If it doesn't find it, it's going to return -1. So what we want to do is see if this is equal to -1. If it is, we're going to branch. So if it is, we want to move the actor. And if it isn't, we want to do nothing. So we have our branch here, and then we're going to grab this, add world offset. Just try and tidy this up a little bit so it doesn't get too crazy with the pins and wires. So now we've got this. So we need to figure out where we're moving this. So this is actually a lot simpler than you would expect. But what we're going to do is for each of these, we're going to get the location of this. Get the actor location of the actor that is overlapping the overlapper. That's not confusing at all. We're going to get the spline. Find direction closest to world location. And then now we're going to need another variable here. This is going to be called dynamic speed, and it's going to be a float. And this is going to be something that we can set. So we can make this instance editable, and we can expose it on spawn. But we're gonna get this location, and then we're gonna multiply it by speed. But basically, what this location is doing is it is finding a point, or you're feeding in a point, and it's finding the closest spot along the spline, closest direction along the spline to that point. So if the point is here, then it's going to be looking this way. And so this is a pretty close approximation of what we need. If you have a really curved conveyor belt and you're closer to the edge, it might grab a point that is inaccurate. So if you have a loop, it could theoretically over time get a little bit of eccentricity and throw you off the loop over numerous successions. So straighter conveyor belt is more accurate for if you have like a perfect circle, it should work fine as well. It is literally just if you have some eccentricity in this, it won't be perfect. So just keep that in mind. But it works pretty well for what we want. So we're going to take this dynamic speed that we created, which should just start off at 1 for our default. Multiply a vector by a float. So we're going to multiply these. And we'll just plug this in real quick just to show you how this will work. But there's something that we want to change after this. But before we get to that, I'm going to add this to moved actors. So whatever is getting moved is not going to get moved twice. So we'll plug that in. Theoretically, this should work out. So you can see I'm being moved along. Oh, I need to make that invisible again, but you can see I'm being moved along here. So that's working out nicely. I can run against it, works fine. Looks pretty good. The only thing that you'll notice is if I rotate this, it's not doing it correctly. So we need to also figure in the rotation of the actor. So we're going to take the scene root and get world rotation, and we're going to rotate vector. We're going to plug this in here, plug that in there, and move these out to make it a little nicer looking. Just do a little cleanup in here. And also, I'm going to go in the construction script and make this invisible again, the overlappers, so they don't show up. Okay, so now it's working correctly. And if I rotate it again, it should theoretically account for that. So the other thing is that now that we have a dynamic speed, we can change that on the fly. We can actually change that while it's running if we wanted to. And you can see that's working. We can also change it to be a negative number, and it'll work in the opposite direction. So you can see now I'm being pushed in the opposite direction. So all that's good. That's a good start. It's functional. Everything is working as it should. You'll notice that visually it's not quite where we want it to be though. So we have this working. It's working nicely, but we want to make it actually appear as if it's moving. Otherwise it'd be very confusing to players. So the way that we're going to do that is we're going to go into the conveyor belt and we are going to pan this material. We're not going to use a panner, however. If you use a panner, you cannot vary the speed at runtime. It will mess things up. So we're going to do this kind of manually, but in essence, what we're doing is panning it. So we're going to create another scalar, and this is going to be called x speed, and this is going to be a default of 0.5. We're going to create another constant parameter, which will be the y speed, and it'll just be 0. We're going to append these two together, so that's our speed that we're pushing objects at, or that's the speed that we're panning the texture, but it will correspond to what we're pushing objects at. We're going to create another scalar parameter, and we're going to call this p time, panner time. This is just going to default to 0, and we're just going to feed a number in here, and this is going to pan our texture for us. So we're going to multiply these two numbers together, and then we're going to add this in to our texture coordinates that we shifted and scaled. Save that. All right, so now we're going to do this with a timeline. You can also just plug this in. You do the whole thing via timeline or the whole thing via a timer, but the way I did this in my project that I'm working on, I did it with a timeline and timer because I have a bunch of different ways that I can interact with these in the game, and this made it a lot easier for me to do things like reverse it on the fly with a button press or stop it on the fly with a button press. But you could do this a bunch of different ways. This is just showing you a couple different ways that you can approach this. So we have a timeline. We want to open that. We want that to be autoplay and looping. We want it to be 2 seconds long. We want to add a float track, and we're going to add points here. So we've got a point 0 and 0, and then we're going to have a point at 2 and 2. You can click this to see the points. So that should be good. So we now have that. And we want to do a for each loop here, not moved actors, on the mesh components. So a for each loop. Oh, come on now. For each loop, and for each of these, we're going to set a scalar parameter on scalar parameter value on materials for p time. And we are going to multiply the float coming out of the timeline by another float, which will be our dynamic speed. And that will basically give us the panning motion. So if I have done everything right, fingers crossed, I hit play, and it's panning now. And you'll see it's panning in the same direction as the movement, because I've set everything up right in terms of UVs and in terms of not buttons, in terms of figures that I'm plugging in all these floats and stuff like that. On your own mesh, you may have to do things specifically a different way. So just keep that in mind, that you might have to fiddle with numbers to get things to work right and to work in the same direction. The other thing you'll notice is that I've worked this out so that the numbers are consistent, and it looks like, at least until you get to places where the UVs are distorting, that the character is moving at the same speed as the conveyor belt. So this works for characters. I can throw in, I have a little physics object. Oh, that's the wrong thing. I have a physics object spawner that can just spawn random physics objects, and those will work as well. So if we watch this here, you see they hit, and then they start moving along the conveyor belt. So that works pretty well. There are a few things to note about that, however. Physics objects with the add world offset tend to work best if they're static mesh objects. They work best if you have sweep and teleport on. If you're moving a character and you were to put this up against a wall, say, so let's move both of these things over here, and we'll kind of observe what the behavior is. Push this over here. Okay. So this character is going to get a little glitchy when we get close to the wall. Physics object will be fine, but you'll see the character kind of starts teleporting. So we don't really like that so much. So one thing that you can do to change that is to cast this to a character. I'll plug this in here. And so if it's not a character, we just want it to keep this behavior. If it is a character, we want it to sweep. So basically everything is the same except we're going to sweep. And then, oh, it's actually moving this for some reason, which shouldn't be happening. I'll have to take a look at that in a second. I figured out what I did wrong. So I didn't plug in this object that we had into the add actor world offset. So instead of moving the character, it was moving the conveyor belt. So you want to make sure you plug this in. But so now we have this. So if it's a character, it will sweep, and if it's not a character, it won't sweep, which kind of cleans up the behavior a little bit. So if you watch, now it's moving correctly. Physics objects work against the wall, and character works against the wall as well. One of the other edge cases I kind of had in my own game that I'm working on is that if the character is their skeletal mesh is simulating physics, then you want to teleport it as well. So you might have a third thing that says, is this simulating physics? And if it is, then have it do add actor world offset with sweep and teleport. But those are just some little edge cases that you might run into with this. But otherwise, it is a pretty simple way to put together a conveyor belt system that you can on the fly add points to, and it will curve and it'll look nice and it will run well. And you can make loops and all kinds of stuff. You can kind of play around with elevation and stuff like that, and it'll make for more interesting conveyor belts. You can do all kinds of stuff with this, and it's pretty simple and customizable. So I hope this was helpful for you. Hopefully you guys can make something cool out of this. It helps you learn about splines and spline meshes, things like that. If you have any questions or issues, put them down in the comments below. If you have any other things that you'd like to see, let me know. Probably for the foreseeable future, I'll just be kind of making videos sporadically whenever I have something that I put in my game that works well as a tutorial. But hopefully you guys like this, and thanks for watching. Hope you have a great day.